Hello everyone, this is easyedu, and in our today's video tutorial we will explain Compton scattering and Compton effect. Later we will derive an equation for Compton shift. Compton effect. Arthur H. Compton in 1923 directed a beam of X-ray of wavelength lambda toward a block of graphite. He found that the scattered X-ray had a slightly longer wavelength than the incident ray, which means that the scattered X-ray lost some of its energy during this scattering process. He further explained that the amount of energy lost depends upon the angle at which X-ray was scattered. The change in the wavelength del lambda between the scattered X-ray and the incident X-ray is called the Compton shift. In order to explain this effect, he assumed that a photon behaves like particles, then its collision with other particles is like that of billiard balls. Here you see these diagrams. This is the equation for Compton shift. We will derive this equation using physical formulas and some mathematics. Let's consider this is the incident photon, this is the scattered photon, and this is the electron after collision. Initially, we assume that electron is at rest, and we assume that the incident photon is like a particle. When this photon strikes this electron, it lost some of its energy during the collision. It transfers some of its energy to this electron, and this electron gains this energy in the form of kinetic energy, while the scattered photon have energy slightly less than the incident photon energy. The energy is denoted by E is equal to h mu, where the momentum is denoted by P is equal to h mu by c. We will use law of conservation of energy and law of conservation of momentum to derive this final equation for Compton shift. P is equal to h mu by c, where mu is the frequency and c is the speed of light. If you don't know from where this equation has come, then look at here. E is equal to mc square. We can write this in the form of E is equal to mc dot c, where m is the mass and c is the velocity. We know that momentum is P is equal to mv, so we can write this equation emc as E is equal to pc, where P is equal to E by c. After putting the value for E, which is E is equal to h mu, which is Planck's equation, then we can get P is equal to h mu by c. The second method for deriving this momentum term is from de Broglie wavelength. We know that the de Broglie wavelength is lambda is equal to h by p. We can write this equation in the form of P is equal to h by lambda. We know that V is equal to c by lambda, where V is the frequency. Then by transferring lambda from here to here, we will get lambda is equal to c by V. After putting the value of lambda in equation number 1, we will get h mu by c, which is the term for momentum. So the incident photon have energy E is equal to h mu and momentum h mu by c. First we will deal with momentum. After that we will deal with the energy term. The momentum of the incident photon is P is equal to h mu by c. After scattering, we will denote this momentum by P is equal to h mu dash by c and energy of the scattered photon by E is equal to h mu dash. The initial momentum of the electron is considered as P is equal to 0 because the electron we consider here is at rest. After striking the electron will gain some kinetic energy. Now we will use trigonometry for deriving further equations. We denoted this scattered photon angle with the x-axis by pi and the scattered electron, after collision by theta. Here you see this scattered photon make angle pi with the x-axis and having momentum p is equal to h mu by c. Now this term h mu dash by c make an angle pi here and its projection along the x-axis. Now we consider this as a xy graph. Now here this h mu dash, its x component is equal to h mu dash by c cos of pi and its y vector is equal to h mu dash by c sin of pi. While the term for the electron is in the downward direction, so we denote this by the projection of p along the x-axis is equal to p cos of theta, and the projection of this p along the y-axis is equal to p sin of theta. But keep in mind here the theta is in the reverse direction, so we consider it as minus theta, and we know that sin minus x is equal to minus sin x. So we put here the negative minus sign. Now we proceed to next slide. Now we apply the law of conservation of momentum. The initial momentum is equal to the final momentum, or the momentum before collision is equal to the momentum after the collision. Before the collision, the momentum is equal to h mu by c, this h mu by c. While after the collision, we have two terms, h mu dash by c and this p. H mu dash by c is the momentum of the scattered photon and plus p is the momentum of the electron. Now we will write this equation in component forms as for x-axis, or for horizontal axis we have h mu by c because the angle this is parallel to the horizontal axis, this h mu by c, and we know that cos 0 is equal to 0 is equal to 1, so we put p is equal to h mu by c for x-axis. Now after the collision, the scattered photon have component h mu dash by c cos of pi. We write it h mu dash by c cos of pi, while for the electron the x component is p cos of theta. Now multiply this equation by c, then the equation becomes this c cancel with this one and this one cancel with this one, while the p become pc by multiplying with c. So h mu is equal to h mu dash cos of pi plus pc cos of theta. Now transferring this term to this side, the pc cos of theta term becomes equal to h mu minus h mu dash cos of pi. So we get this equation. Now by taking square on both the sides of this equation, the equation becomes p square c square cos square theta is equal to, this is a, this is b. We know that a minus b is equal to a square minus 2ab plus b square. So this term becomes h mu whole square minus 2 h mu into h mu dash cos of pi plus h mu dash square cos square pi. This is a simple mathematical formula. A plus b or a minus b is equal to a square, or a minus b whole square is equal to a square minus 2ab plus b square. Now we deal with y-axis. For y-axis, we have the y component of P is equal to h mu by c is equal to 0, because for y-axis we use sine theta, and the sine theta here is 0 because this incident photon have theta is equal to 0 here. This is parallel to the horizontal axis. So for this reason we put P is equal to h mu by c is equal to 0. Now after the scattering we have the y component of h mu dash by c sine of pi is for the scattered photon h mu dash by c sine of pi minus p sine of theta. This minus p sine of theta because this is in the downward direction. So we consider this h mu dash by c sine of pi positive and p sine of theta negative. Now transferring this term into the left hand side, we get p sine of theta is equal to h mu dash by c sine of pi. We follow the same procedure we have followed for the x-axis. Now we multiply both the sides by c and then we take square of both the side. So we have pc whole square by multiplying this term with c and c. We get pc whole square sine square theta is equal to h mu dash whole square. This c cancel with this c, so the only term is h mu dash whole square sine square theta. Now we have two equations, one for x-axis 2a and the other one is for y-axis 4a. Now adding these two equations 2a and 4a, this is for the x-axis and this is for the y-axis, we add these two equations and then we will rearrange them. After adding these equations, pc whole square cos square theta plus pc whole square sine square theta is equal to h mu whole square minus 2 h mu dash cos of pi plus h mu dash square cos square theta, cos square pi plus h mu dash whole square sine square pi. This is this term. Now we know that we will take common pc whole square from this term. We will get pc whole square cos square theta plus sine square theta is equal to h mu whole square minus 2 h mu dash cos of pi plus, now here you see these two terms h mu dash whole square plus h mu dash whole square. We will common this h mu dash whole square and h mu dash whole square from these two terms. So we get h mu dash whole square cos square pi plus sine square pi. We know that cos square pi plus sine square pi is equal to 1, and similarly cos square theta plus sine square theta is equal to 1. The remaining terms are pc whole square is equal to h mu whole square minus 2 h mu dash cos pi plus h mu dash whole square. We name this equation as equation number B because we will later need this equation for further calculations. Now we deal with energy terms. Here the total energy is denoted by E is equal to kinetic energy plus mc square. Kinetic energy is the energy of the photon after collision plus mc square the rest energy of the electron, and E is the total energy of the electron after collision. Now we will use this term E is equal to mc square whole square plus pc whole square whole under the root. If you don't know from where this equation has come, then one of my previous video have explained this about this equation. You can watch that video. This is the relativistic energy and momentum relation, and this equation is applicable to both inertial and non-inertial frame of references. This is the total energy of electron. So we have two equations for total energy of electron. E is equal to Ke plus mc square. Mc square is the rest energy of electron. Ke is the energy gained by the electron. The total energy of the electron after scattering is equal to Ke plus mc square. And this equation is derived already in my previous video. Is the relativistic energy, and this energy term is applicable both for non-inertial and inertial frame of references. Now we apply this energy term here. E is equal to mc square whole square plus pc whole square whole under the root. By comparing equation 1 and 2, we will get whole under the root mc square whole square plus pc whole square is equal to kinetic energy plus mc square rest energy of electron. Now by taking square on both the sides, we will get mc square whole square. This is square. This square cancel with this one. The remaining term is mc square whole square plus pc whole square is equal to, now again a plus b whole square formula, ke square plus 2ke mc square plus mc square whole square. Now we transfer this term to the this term cancel with this one, and the remaining terms are pc whole square is equal to kinetic energy whole square plus 2 mc square ke. Now we know that the total energy before scattering is equal to h mu, and after the scattering the energy split into two terms. One is the scattered photon energy, this one, and the other is the kinetic energy of the electron, this one. So the kinetic energy of the electron becomes equal to h mu minus h mu dash. We put this value for kinetic energy in this equation. By putting the value of kinetic energy in this equation, this becomes pc whole square is equal to h mu minus h mu dash whole square plus 2 mc square h mu minus h mu dash. Now again this is a minus b whole square formula. pc whole square is equal to h mu whole square minus 2 h mu dash plus h mu dash whole square, and the remaining term is plus 2 mc square into h mu minus h mu dash. We name this equation equation number D. Now we have one equation pc whole square is equal to this one we have derived, and now the second term, this is derived from the previous section, this is this one, and now on the second equation we have is pc whole square is equal to this one. Now what we are going to do, we are going to compare these two equations, equation D and equation number B. By comparing these two equations, we will get h mu whole square minus 2 h mu dash plus h mu dash whole square plus 2 mc square h mu minus h mu dash is equal to this whole term is this one. Up to here, and the second term is h mu whole square minus 2 h mu dash cos of pi plus h mu dash whole square. This whole term is this one. Now this h mu whole square will cancel with h mu whole square, while h mu dash whole square will cancel with this h mu dash whole square, and the remaining terms are minus 2 h mu dash plus 2 mc square h mu minus h mu dash, this one is equal to minus 2 h mu dash cos of pi. Now rearranging this equation we will shift this equation to right hand side. The remaining terms are 2 mc square h mu minus h mu dash, this one, and when we transfer this equation from left side to the right side, it becomes 2, the sign change, and it becomes 2 into h mu dash minus 2 h mu dash cos of pi. Now we will take 2 h mu dash common from this right hand side. 2 mc square h mu minus h mu dash is equal to 2 h mu into h mu dash into 1 minus cos of pi. Now dividing both sides by 2h square c square. By dividing both sides by 2h square c square, we will get this h and this h become h square and cancel with this one. This 2 cancel with this 2. Here this 2 will cancel with this 2, and the remaining terms will become this c square will cancel with c square. So the remaining terms are m. Now we take hc common from this term. By taking hc common from this term, the remaining term is, we get mhc. The hc, after taking common hc, this become mu by c, and this become mu dash by c. So we have mhc into mu by c minus mu dash by c whole divided by h square. This square become cancel with this h, and the left side the right side become mu by c. This is 3 square, so we can write this c dot c. So mu by c, mu dash by c is equal to 1 minus cos of pi. Now we have mc 1 over lambda minus 1 over lambda dash by h is equal to 1 over lambda dash into 1 minus cos of pi. Now we transfer this, we multiply this again by h by mc by multiplying both sides by h by mc. This term becomes 1 over lambda minus 1 over lambda dash. This mc become, we can write this as h by mc. So we transfer this term to this side and this h to this side. So 1 over lambda minus 1 over lambda dash is equal to 1 over lambda dash h by mc into 1 minus cos of pi. Now we are going to multiply both the sides by lambda dash. By multiplying this side by lambda dash, this will become lambda dash by lambda. Lambda will cancel with this one, and this, by multiplying this 1 over lambda dash with lambda dash, this lambda dash will cancel with this lambda, and the remaining term is lambda. Now lambda dash will cancel with 1 over lambda dash. What we get, lambda dash minus lambda is equal to h by mc into 1 minus cos of pi. This relation is known as Compton effect, where the term h by mc is equal to lambda c. We name this the Compton wavelength. This is a constant, and this cos pi, so the lambda dash minus lambda depend on the value of pi. when pi is equal to 0. This equation becomes lambda dash minus lambda is equal to h by mc. So this relation which we have derived, lambda dash minus lambda is equal to h by mc into 1 minus cos of pi, is known as Compton effect, and this lambda dash minus lambda is known as Compton wavelength. Where the term lambda dash minus lambda is the change or shift in the wavelength of incident and scattered photon. Okay, this is enough for today, and thank you for watching. Don't forget to subscribe and comment your questions. Thank you.